So as I go through this, I want you to bear with me. Don't get overwhelmed at first. Don't shut me out, because we are going to start with baby steps. I'm not going to throw everything at you at once. We are going to do this in pieces, but I have to explain the whole thing in general for you to understand the pieces as we go through it. And then I have a very exciting thing to show you later. This is what happens when I have extra time on my hands for you. Take a highlighter. Because as you look at, we're going to be graphing y equals the sine of x and y equals the cosine of x. Now as you look at those graphs, they look nearly identical, don't they? They don't appear to have a whole lot of difference to them. But look really closely. What is the difference between the sine wave and the cosine wave? Look at the origin, what's going on. Sine starts at 0, whereas cosine starts at 1. There's a reason for that. I want you to highlight just one period of sine. So if I highlight one period of sine, it's from 0 to 2 pi. It looks like a sideways S. S for sine, sideways S. If I highlight one period of cosine from 0 to 2 pi, it looks like an upside down bell curve or a sideways C for cosine. Now don't they look vastly different? Wouldn't you agree with that? I would certainly say so. So, how do we get there? Look over here to the left. You need to know how to find all of this basic information. The period, the horizontal vertical asymptote, the amplitude, and how to find your key points. Key points are key. So we're going to do it bit by bit. Down here, we've written for you how to find all that stuff. So let's just start with amplitude. Amplitude is how high above the x-axis and how low below the x-axis your graph is. So the amplitude is your distance above and below the horizontal axis, which for right now is the x-axis. That can change, but for right now is 1. For this one, the amplitude is 1, because notice that the highest point it goes up to is 1, and the lowest point that it goes down to is negative 1. And same thing for cosine. We get that by looking at this general formula right here. You can have y equals something, some number in front of sine or cosine, and then you can also have some number in front of x. You could have something added or subtracted to your x value, and then you can have something added or subtracted outside. If you think about our transformations in the past, what is this going to do to the graph, something being added or subtracted to the outside of the function? It's going to move you up, down, right, or left. Up or down, right? And then this inside here is going to do what? Move you left or right. You are not to do any problems tonight in Math Excel that involve addition or subtraction, because we're not going to talk about C or D today. We'll do that on Monday. But those are your items that are going to affect your horizontal and your vertical axes, because those will be moved. They're kind of like asymptotes in the sense that those can be moved. But they're not asymptotes in the sense that we will cross them. Your period is generally from 0 to 2 pi, but that period can change. And what changes the period is the coefficient of x. So whatever is in front of x is going to affect this period. And I've written that down here. So if you look here, we find our amplitude, and I want you to add here to take the absolute value of A. A is whatever might be in front of this word sine or cosine. Now I say absolute value because what if I have in front of y equals sine of x? What if I have y equals negative 5 sine of x? What if we learn that negatives do to our graphs? They flip it, which means it's a reflection. So the negative on A is not the amplitude, it's the reflection. So that's why when I ask you for amplitude, 100% of the time you're going to give me a positive answer. The negative will, and we'll look at later whether that reflects over x or y, but honestly you should know that right now. What is a negative outside the function going to do? Is it going to affect x or y? is going to affect y. And so you flip it over the other axis, x. And so if we have a negative inside, it should affect x, so it's going to end up reflecting over y. So that really hasn't changed. So we're still using our previous knowledge, but I will give you some easier ways to deal with it. Let's look at why the sine and cosine graphs are what they are. So let's review the unit circle. What is the radius of the unit circle? How far is it from the origin to this point? What is it? 1 unit. The unit circle has a radius of 1 unit. And so the points, our north, south, east, west points are 0, pi over 2, pi, 3 pi over 2, and then we round the bend again and hit 0 again with 2 pi to make a full revolution. 1 revolution is considered 1 period. All we've taken is I've taken the circumference of this circle and I've opened it up and we've graphed it here. Notice that my x-axis is partitioned into these 5 points here. 0, pi over 2, pi, 3 pi over 2, and 2 pi. That encompasses that 1 period. Now, how do we get the ups and downs of the graph? Let's recall the ordered pairs. So what's the ordered pair at 0? It's 1, 0. Then I have that radius of 1. At pi over 2, what is it? 0, 1, pi, negative 1, 0, and 3 pi over 2. 0, negative 1. And of course, 2 pi is going to be the same as that one. Recall, on the unit circle, those ordered pairs go alphabetically x, y. And then x and y correlate alphabetically to cosine, sine. So on this ordered pair, the cosine is 1, the sine is 0 at 0 radians. So look at the graph. At 0 radians right here, I'm doing sine. What's the sine of 0? What's the sine at 0? It's the x value, 0. Let's make a t-chart. So I'm going to let my x values be all these pink numbers here, those north, south, east, west points on the unit circle. So I'm going to let my x be 0, pi over 2, pi, 3 pi over 2, and 2 pi. Those are key points, by the way. When I replace x with 0, I'm finding the sine at 0 radians. The y value at 0 radians is 0. So it makes sense that my ordered pair sine will start at 0, 0. So there's this point right here. Then we move along the circle to pi over 2. At pi over 2, what's the sine value? 1. So at pi over 2, I'm going to go all the way up to a y value of 1. So there's that point there. Then we come to pi. What's sine? 0. So at pi, I'm back at the x-axis at 0. There's that point there. Come around to 3 pi over 2. What's sine? Negative 1. So we finally dip down below the x-axis to a y value of negative 1. And finally come back to 2 pi to a sine of what? 0 again. And that rounds it out. We can do the same thing with cosine. So I'm going to create an xy table for cosine. Y equals the cosine of x. So we use those same key points, 0, pi over 2, pi, 3 pi over 2, and 2 pi. They come from the unit circle. This time, when I put these radian values in for x, cosine is the x value of that ordered pair. So, tear apart the unit circle. At 0 radians, what's cosine? 1. So that explains why at 0, the origin, we start up at 1. There's that one. Go up to pi over 2. What's cosine? 0. So we hit the x-axis. Then at pi, what's cosine? Negative 1. So at pi, we go dip down to negative 1. 3 pi over 2, what's cosine? What's the x value? 0. So I'm back up at the x-axis, and finally at 2 pi, we're back up to 1 up here. So follow along. These 3 points in here are your 30, 45, and 60 angles. They're the ones that are in here. They just didn't show them along here either. But think about this. Let's think about the sine of 30 degrees. Does anybody know what the sine of 30 degrees is? What's the y value at 30 degrees? I'm going to show you something real easy to do this shortly. Well, the sine at 30 degrees is 1/2. So if this is pi over 6, isn't that about halfway up? And if we took radical 2 over 2 at pi over 4, we'd be a little bit higher. And then at pi over 3, if we took radical 3 and divided by 2, we'd be almost at 1. And so that's what those little dots are for, just in case you're interested. Notice that we don't usually like to plot those because they're harder to plot, aren't they? They're decimals. Questions before we start some problems now. There's your overview. All right, so let's just look at a problem. We're going to start with baby steps. Remember, you have this thing called an arm that has what attached to it? A hand. So if you get lost or confused, I want you waving that arm and hand madly and stop. Because if you have that question, so does somebody else. You don't ask it, we're never going to know. So do you have any questions before we start? All right, so look at the first example. Y equals 4 times the cosine of x. What's the difference between that and y equals cosine of x? There's the only change that's been made. You have this 4 in front. And the 4 represents what here? A, B, C, or D? A, which is amplitude. So we're affecting amplitude. And let me just do a little side note here. Your textbook, by the way, uses a slightly different formula. I only want you to be aware of that for the following reason. Write this down in case you see it. You shouldn't be using it this weekend, but just in case you see it. And I'll explain how to get around it. It's just, I think it's a harder way to learn it, but that's just me. Y equals A. They still use sine or cosine. But instead they have a parentheses here. Here's the B. They have another set of parentheses, and then they have x minus h, n parentheses, another parentheses, and then plus k. The only difference between the two is that my d is their k. Just a difference in letters. But notice what's inside here. And what's inside here. That's where the difference occurs. They factored the coefficient of x out in front. So that whenever you have a coefficient of x and something being added or subtracted, the shift right or left is not quite so clear cut. And so this horizontal change down here, this is what your textbook will refer to as a phase shift. So if you see anything in your homework tonight referring to a phase shift, don't do that problem. So you're just going to skip those and do only the ones that don't have addition or subtraction signs in them. So for right now, you're skipping that. I'll discuss phase shift and all that kind of stuff later. So let's just look at a change in amplitude. So what's our amplitude? 4. That means that my graph is going to go no more than 4 above the x-axis and no more than 4 below the x-axis. That is our limit, so to speak. Our period, we have to calculate each and every time. So we always use 2 pi because that's the general period for sine and cosine. B is the coefficient in front of x. What's in front of x? 1. So technically there's a 1 here in front. So I'm dividing my period by 1. And so I actually get 2 pi. My period has not changed. Because I don't have anything added to or subtracted from the outside of the function or added to or subtracted to the inside of the function at x, my vertical and horizontal axes do not change either. So let's think about, because some of us are still struggling with this. Here's my vertical axis. What axis does it go through? X. So that means that the equation is x equals, and it goes through the x-axis of 0. So vertical goes through the x-axis, that's why it's x equals 0. Horizontal goes through what axis? Y-axis. So it is y equals 0. So those are staying put. Then we have to figure out the increments that our key points are going in. Are they going by 1/2 pi like the ones above did? Are they going by pi over 4? Are they going just by 2's? Because that can happen. So let's look. This is how you do it. These little helpful hints, by the way, here on the side are going to be taken away from you. So on your quiz that I give you on Monday, they'll be there. But by the time you take the test over this, they're going to be gone. So you have to learn these on your own and know what they are. They will not always be there. So to find our key point increments, we're going to take our period here of 2 pi, and 100% of the time you will split it or divide it in fourths. If I take a loaf of bread and I make 4 cuts, how many pieces do I have? 4 cuts creates how many pieces, not 4 pieces. Think of a sandwich. If you make 1 cut, how many pieces do you have? 2. So for every cut that you make, you end up having 1 more cut than all of your cuts. So if I cut this into 4, I'm really going to end up with 5 pieces. I'm not, look at it this way. What do I end up with? What does that reduce to? Pi over 2. My key points, and I always want 5 of them. You want 5 key points within your period, because I'm taking my period of 2 pi, and I'm cutting it into, so I have 5 key points. 100% of the time, for now, you're going to start at 0. Your first key point is going to be 0. And for your note purposes, please show what I'm going to show in here. You'll start to do it in your head, but you're going to forget by the time you go and do your homework, how did you come up with them? You're going to take this increment and you're going to keep adding it until you have 5 key points. So there's 1. 0 plus pi over 2. Isn't that pi over 2? Then I'm going to add pi over 2 again. What's 1/2 plus 1/2? 1/2 plus 1/2. 1 pi. So my third key point is pi. Then add a half. So what's 1 plus a half? 1 1/2, which we like to write as 3 pi over 2. And then that gives me 4. I want 5 total, so I have to add a half again. And what's 1 1/2 plus a half? 2. So I get 2 pi. So there's my 5 key points. And the purpose of that was I need my amplitude and my key points to partition my vertical and horizontal axes. I will always start with my vertical axis first, because my amplitude is how high or how low I'm going to go. So if this is 0, this is going to be 2, and this is going to be 4. This will be -2 and -4. Switch. Huh? Yep, that's the last one. All right, and then my x-axis is going to be my key points here. I like to spread it out a little bit so I have room to write and room for my graph to be plotted, yes. Because I know I have to go up to 4. My amplitude is 4. So the amplitude tells me how high I have to go up. And you'll see me adjusting this depending upon what my amplitude is. And so for my x-axis, I'm gonna do the same thing. I'm gonna take every grid line and I'm gonna go by every other grid line as my key points. And the reason for that is I want to have room to write. If I use every grid line as a key point, my graph is all squished together. And I want to spread it out just a little bit so I can see the shape of the graph and ensure that I'm doing it correctly. And then I'm going to label one full period with my key points. So this is 0, this is going to be pi over 2, pi, 3 pi over 2, 2 pi. So that's one whole period. Why? Because I know my period is 2 pi. Then from there you can keep labeling every mark if you want to. I like to just label every other one. And so if you look at every other one on mine, it's going by pi. So that means that this will be 3 pi, 4 pi. If that bothers you, you can label every one if you want. And then on the negative side, I like to label as much of a full period as I can, so I don't mess up my pattern when it comes time to graphing. So this is negative pi over 2, negative pi, negative 3 pi over 2. Questions so far? This is all just kind of however you want to do it. You got to label. If you don't label, I'm going to assume every hash mark is 1. I chose, after I do one full period, then I just choose to label every other one, because people ought to be able to tell what the ones in between are. So that's 2.5, 3.5, right? If you want to label those as 5 pi over 2, so forth, you could, but that's just extra work. I want one period label, and you'll see why in a minute. So it'll be good to start. Then, oftentimes when I'm graphing, I'm going to sketch up here just kind of what the graph of cosine looks like to remind myself where I start. And so you're going to start and graph one period only first to check your graph and make sure you do it correctly. It's very easy to graph sine when you're supposed to be graphing cosine and vice versa. And if you forget where you start, go back to the unit circle. Think about it 0, because we're starting here at 0. At 0, the order pair is 1, 0. Cosine is 1, so where should I be at 0? At 1. So I know at 0 that I should start at 1, but the problem is my amplitude is no longer 1. It's 4. So I have to go up to 4. And by the way, here's how the pattern works. Notice that every other increment, every other key point hits what?
0.
The x-axis, and it is called a 0. So Math Excel asks you to label the zeros between 0 and 2 pi. You'll be labeling those 3 points. On cosine, there are only 2 zeros in one period. And so notice that the pattern starts off for cosine, it goes up, 0, down, 0, up, 0, down, 0, up. It's always an up-down pattern with 0 in between. Same thing with sine, but it depends on where you start. With sine, you start at 0. So it's 0, up, 0, down, 0, up, 0, down. So it's still an up-down pattern. It's a matter of where you start. So we're going to start that pattern here. We started up. The next key point, every other key point is always at 0, the x-axis. So I go up, 0. Next increment is down to your amplitude of -4. Next increment is at 0. Next increment is up to your amplitude. As I alternate ups and downs, and in between those are zeros. And then sketch that and look at it. Does that look like the graph of a cosine? Upside down bell curve, sideways C, right? Then you can fill in the rest of the pattern. So I started up, so I go to 0, then down, then 0, then up, then 0. Then on the left, I already started up, so I want to go to 0, down, 0. All about a pattern. If you can do the math, you just have to know your patterns of up, downs, and zeros. Correct, and down too. Whatever, and so you have to know that amplitude. And so that will change. The coefficient that's in front of sine and cosine. Any other issues, problems, or concerns? Okay, we're going to look at one more amplitude change. Can I flip this, or are we still writing? Okay. Sarah, you okay? Sure? Don't be afraid in. Okay. Can I flip? All right, so let's look at the next one. It's still an amplitude change. Nothing else is going on. But this time we're doing sine. Yes. Why did I continue to graph after this? Because you have to fill in all of your graph. But I will always start with one period so I can check myself, because it's very easy to do all of this work and then start here down at 0, 0 and start graphing sine. So you want to stop yourself and think, did I just graph cosine? Because I will make that mistake all the time, so you have to stop and just check yourself. Because I hate to go through all of this and graph sine when you're supposed to be graphing cosine. Okay. So on this one, what represents amplitude? So 1/2. So that's the only thing that's different. So our amplitude is 1/2. That means we're only going to go up 1/2 and down 1/2. So that's really squishing it down. And so you're going to see me stretching out my increments a little bit, and I'll show you how to do that in a minute. So let's go ahead and find our period. So our normal period is 2 pi for sine. But we're going to divide it by b. What's the coefficient in front of x? So because it's 1, that's why we're dividing by 1. And so our period stays at 2 pi. Since our period stays at 2 pi, that means we're still having the same key points as we just found. But we're going to show it again. So I don't have anything added or subtracted outside the function or inside the function with x. So it has my vertical and horizontal changed. No. Vertical is what equals? X equals 0, and horizontal, y equals 0. To get your key point increment, you're going to take your period here of 2 pi that we calculated, and 100% of the time you're going to divide it by 4. Doesn't that give us again pi over 2? I will show you how the period will change in a minute, but for right now we didn't do anything that would change the period. So starting, for right now, we're always starting with 0, and you're going to add those increments of 1/2. So just like we did before, we're going to come up with those same key points. For note purposes, I would highly suggest you put it in there, in case you're going to forget, especially over a few days. How many key points do I always want? 5. So then we're ready to partition my vertical and horizontal axes based upon my amplitude and my key points. This time my amplitude is not 4, it's 1/2. Isaac, you need to take those out. You could make this 1 like we just did on the other side, but then this is as high as your graph's going to go. It's going to get really teeny tiny. My suggestion would be to stretch it out a bit and make this 1 so that one grid line is 1/2. It makes it easier to get it all in there, you're not squishing it in. It's your choice. But that's what I would suggest. So then that means that -1 is down there. And then again, I'm going to partition this into every other grid line for my key points. Because I want room to write my key points in. Plus, the fewer grid lines I have, the less periods I have to graph. So then I want to label one full period of key points. So this is 0, pi over 2, pi, 3 pi over 2, 2 pi. Like one full period. And then every other one. If every hash mark is 1/2 a pi, then 2 hash marks is 1 pi. So that's why I'm going to 3 pi's and 4 pi's. For your negatives, I would suggest you label a full period as well, or at least as far as you can. Then sine has a very distinctive pattern, so I like to write it here to remind myself of where I start. Again, if you forget where you start for sine, think of the ordered pair at 0 radians. That ordered pair is 1, 0. Sine is the y value, so sine is 0. So at 0, I start at 0. Remember, you're going every other key point is at 0, x-axis, and then we go ups and downs. So if I start at 0, I'm going to go up for sine. So at this one, I go up, but I only go up to my amplitude, which is a half. Next key point is back to 0. Next key point this time is down, but only to negative a half. Next key point is 0. That finishes one full period. And as you can see, it's shorter than the last one. And then you're going to finish that pattern once you look at it and go, yep, that's a sine curve. My amplitude is a half. It appears to be good. Finish out that pattern. So I started here at 0, so I'm going to go up, 0, down, 0, up. And on the left, I was already up, so from 0, I'm going to go down, 0, up. How are we doing with that? Good, bad, okay? Some of you are going to go, this is so simple. And others of you are like, I don't think I have a handle on it. That's normal. The more practice, the better you get at this. Extremely vitally important that you're writing down your problems tonight and doing that with that when you're working on Math Excel. Don't sit there with nothing in front of you. I can't emphasize that enough. And I'll find out on Monday. All right. So then we're going to do graphing with a change in period. Look at example 2. If I were you, to graph the change in period, I have to know what the coefficient of x is. In order to find out what the coefficient of x is, because x is being divided by 2, if I were you, I would rewrite this as y equals the sine of, take x out of the fraction, what fraction do you have? What fraction? 1/2, right? So isn't the coefficient of x 1/2? And isn't that b? And b affects the period. So this right here, my coefficient, is b, and b affects that period. Notice that we don't have anything affecting amplitude. What is our amplitude? My amplitude, I have nothing but 1 in front of sine. So my amplitude is the normal 1. But my period, I'm going to take the normal period of sine, which is 2 pi, and divide it by b, the coefficient in front of the x, which in this case is, oh how fun, we get to divide 2 pi by 1/2. When we divide by a fraction, what are we really going to do here? Multiply by the reciprocal, so it's really 2 pi times 2, which is 4 pi. So what you have discovered is a fraction less than 1 actually stretches out the period to a longer period. Whereas if this is a whole number greater than 1, it's going to shorten this because we're going to divide 2 pi by a whole number. It's going to make it smaller. So we actually get a horizontal stretch here, don't we? True? Okay. Then do I have anything added to or subtracted outside or inside the function? Nope. So my vertical and horizontal axes don't change. So vertical is still x equals 0. And horizontal is still y equals 0. Those are 0. Then we're going to find our key point. So to find your key point, the key point's going to change this time because our period changed. When the period changes, your key points are going to change because we're still going to have 5 key points, but now I have a period of 4 pi. I have to split 4 pi and cut it 4 times. So we're going to take that period we just calculated of 4 pi, and 100% of the time you're going to divide it by 4. What's nice is I get what? Pi. It's very easy to count by pi. So again, for now, you are starting out with your first key point as being 0. You're going to add increments of pi. So I get pi. I'm going to add an increment of pi. So I get 2 pi. Add another pi. I get 3 pi. And that gives me 4. How many do I need? 5. So my last one is 4 pi. For now, your period and your ending key point should be the same, if you've noticed that yet. So let's partition our vertical and horizontal axes based upon the amplitude and the key points. So my amplitude is 1. Typically with an amplitude of 1, I will stretch this out and have my hash marks here go by halves because I don't want to squish it too much. So I'm going to make that 1 and make this negative 1. Then my key points, I'm still going to go by every other grid line for my key points. I'm going to mark those in here. And of course this is 0. But every grid line that I marked in here is a key point. So from 0, this is now pi, 2 pi, 3 pi, 4 pi. And then from there, because that's one full period, from there you can just mark every other one, or you can continue to mark every one if you want to. But I'm going to mark every other one. So that would be 5 pi, so this is 6 pi. So that's 8 pi. And then negatively, I would mark as much of a full period as you can. So negative pi, negative 2 pi, negative 3 pi. We did so far. Pattern. You've done all the hard work up to this point. It's all about the pattern. For some reason, students can do the math, but they can't plot points. It's a pattern. We're doing sine. Sine looks like this. Do we start up or down with sine? Think of the order pair 1, 0 at 0 radians. The y value, which is sine, is 0. So we start down. And then every other key point is up or down, and then every other one is x-axis. So I'm already starting here on the x-axis, which is 0. So I'm going to go up for sine to my amplitude, which is 1. So I go up, 0, down to negative 1, 0. That completes one full period. Does that look like a sine curve? Sine for x, yes. So then finish out the rest of the pattern. So even though I've only labeled every other one, I'm going to go up, 0, down to negative 1, 0, up. And then negatively, I already went up, 0, so I'm going to go down, 0, and up. Are you okay with that? Let me show you one thing before we move on to the last problem. So it looks like, if you look at the last two that we just did, it looks like these two are fairly identical with the exception of their heights. Wouldn't you agree? They're both sine. This one I partitioned the x-axis by half of pi's. This one I partitioned by pi's, but I kept the same increments. In other words, I changed the scale. So of course they look very similar. So here's what I'd like to do. And you can do this in a pencil that's dashed. I'm going to use green. But I'm going to plot this on this one up here. And I'm going to label it with this equation. So at 0, I would be at 0 here. But at pi, which is right here, I went all the way up to 1. So I'm going to put a green point here at 1. At 2 pi, which is here, I'm back to 0. At 3 pi, I'm down here at -1. So 3 pi, I'm down here at -1. And then at 4 pi, I'm back to 0. So really, on the same scale, this is one period right here. So that right there is one period versus that one. And then this one is y equals the sine of 1/2 x. One period for this one period for that one. It's twice as big. And their amplitudes are different. So they are vastly different, but when you change the scale, they are kind of forced to look the same. So I wanted you to understand that even though I'm giving you license to keep the scales like this, so that your pattern is easier to do, they actually, these transformations do change the look of the graph. Any questions before we do the last one? Okay. The last one's fun because what's in front of x? Pi. Some of you are thinking, well, that doesn't sound like fun. Well, whatever's in front of x is going to affect the period, which is our b. There's nothing in front of sine, so what's the amplitude? 1. Our period, we're going to take our normal period of 2 pi and divide it by what you see in front of x, which in this case is pi, and this is y. That's fine. What do you get? 2, because the pi is cancelled. So our period is just 2, not 2 pi, it's just 2, which is really easy for you to think in terms of partitioning. So again, I have nothing added or subtracted inside or outside the function, so my vertical and horizontal axes are x equals 0 and y equals 0. But our key points, we're starting off with 2 as our period. Does that change? 100% of the time you're going to divide it by 4. What do I get? 1/2. So my key points are going to go in increments of 1/2. Where do I start? What's my first key point? 0. And you're just going to add halves from there. So I get 0. My next key point is 1/2. 1/2 plus 1/2 is 1. 1 plus 1/2. 1.5, which is 3 halves. 3 halves plus 1/2. 1.5 plus 1/2 is 2. Doesn't that give me my 5 key points? And notice that my period is 2 and I ended with 2. So now you're ready to partition based upon your amplitude and your 5 key points. So again, you can choose, but I choose to go by halves on the vertical scale and make this 1 so that I have room to write. If I go by 1s, when I label my x-axis, my labeling gets in the way of the graph. And on the x-axis, I'm going to go every other grid line. And then you want to label one full period. There's no pi's in this one, so we have 0, 1/2, 1, 3 halves, and 2. So if every other increment is 1/2, and if I go by 2 increments, it's 1. So this will be 3 and 4. And then on the left, negatively, I like to label as much of a full period as I can. We are still graphing sine. True? So sine looks like this. It starts down and moves up. So your pattern goes 0, up, 0, down. 0, up, 0, down. It's all about where you start. Sine starts at 0. So every increment, I'm going to follow my pattern up to the amplitude. So my amplitude is 1, so I go up to 1, to 0. Down to negative 1 to 0. That's one full period, and that does look like a sine curve. Finish it out. We can have up to 1, 0, negative 1, 0, up. So on the left, we're going to go down, 0, and up. Feel comfortable to do this on your own? We're going to find out. So when you do your math Excel homework, don't do any problems that mention phase shift. Don't do any problems that mention or that have an addition or subtraction sign in them. Okay?